Today we are going to be learning how to properly use a standard military map for land navigation. The materials required for this exercise will consist of one 1 to 50,000 scale military map, a protractor, paper, and a pen. Here we have a map of Fort Hood which we will use for this lesson. There are several key tools and diagrams printed on the map that we will need to navigate. In the lower left you will find the map legend. The legend consists of symbols and signs as well as what each corresponds to in the world around you. In the center of the lower portion of the map you will find the distance ruler. The scale of 1 to 50,000 will be important later when using the protractor. We will be using the meters portion of the ruler. To the right of the ruler you will find the declination chart. This chart is used to calculate the difference between grid north and magnetic north. Grid north is simply straight up along the lines of the map. Magnetic north is the direction the north arrow on your compass will point you. The chart will give you directions how to calculate from grid to magnetic and vice versa. It is important to note that this angle will change between maps and as such must always be consulted. The first step in land navigation is plotting locations and getting your grid coordinates. Looking around the outside edge of the map you will find numbers by each of the intersecting lines. These numbers correspond to the 1 kilometer square grid squares. For this exercise our starting point will be the peak of Jack Mountain, identified by the red square. To obtain our 4-digit grid we will utilize the numbers at the edges of the map, placing the lateral number first, then the vertical. Our point is in the 16th lateral grid square and the 57th vertical grid square. This gives us a 4-digit grid of 1657. However, a 4-digit grid is only precise to 1,000 meters and is unsuitable for land navigation. We will need to find our 8-digit grid, which is accurate to 10 meters. To find an 8-digit grid we will need our protractor. Using the triangle cutout labeled 1 by 50,000, we will place the bottom right corner of the triangle on the bottom left corner of the target grid square. Then we will drag the protractor to the right until the vertical right side of the triangle is in line with the point. The point on the bottom of the triangle which intersects with the left border of the grid square is the next lateral number. On the right side of the triangle, where the point lies on the vertical ruler, is the next vertical number. Using this method we have an 8-digit grid of 16705735. To navigate between 2 points you will first have to plot your destination using the previous method. Then using the protractor, you will place the center over your starting point and draw a straight line to the destination point. For land navigation, you will use the degrees measurements, which go from 0 to 360, not the mils measurement on the outer ring. The degree on which the line falls will be your grid azimuth. You must now refer back to the declination chart to calculate your magnetic azimuth. In this example, we will be subtracting the GM angle of 7 degrees from our grid azimuth of 80 degrees, giving us a magnetic azimuth of 73 degrees. When using a military compass, you will hold it level at the cheek of your dominant eye and rotate yourself until the desired degree is under the black line parallel to the viewing window. Now that we have a direction to move, we need a distance to our destination. A simple field expedient method is to use a piece of notebook paper as a ruler. Place the edge of the paper in line with both points and make a mark for each point. Next you will bring the paper down to the ruler, ensuring to use the meter ruler. As you can see, our destination is just short of 6 kilometers. To measure the excess, we will mark the paper again at the last clear point of measurement. Then you can move the paper to the more precise portion of the ruler to get a final measurement of 900 meters, bringing our total distance to 5.9 kilometers. While this method of drawing a straight line, known as dead reckoning, will give you the shortest distance, it is not usually the best route to take. Natural obstacles and the mission environment will dictate routes. In this image is an example of a more realistic route, taking terrain into consideration. To navigate this, you would need to calculate the distance and azimuth of each section, as well as choosing terrain features or man-made objects which you could use for terrain association along the way. Land navigation is a perishable skill which requires routine practice to perfect and maintain.